So watch demonstrations. Hopefully this will work. Are you guys able to access that on your Schoology? Oh, you can't see anything. Why didn't you tell me that? This reader, there's nothing up on the screen. So on this watch demonstrations page, and then I'll do it by hand for you too. We're going to learn today how to, so all of these demonstrations, come on buddy, here we go. Let's pause for station identification. Today we're going to learn about constructing perpendiculars. It's pretty easy. Perpendicular bisector of a segment. So I'll run this video and then you'll kind of follow along by hand. So perpendicular bisector segment. All of these are on your. There's a link to it. Okay. So to make a perpendicular bisector, we're gonna run. Here it is. You take your compass. You make a mark up there, a mark below. Then you take your compass, flip it over to the other side, a mark above, a mark below, and then you just take your straight edge and you're done. So that's how you make a perpendicular bisector. Isn't that cool? You want to see it again? You want to follow along with me?
That was cool.
Thanks. Why don't you guys
see her regular class
next month? Okay. So why don't you guys practice one with me. So take your straight edge, take a piece of paper, okay, and just make a line segment, okay? Make a line segment. Make a line segment of any length. But it's got to be a segment, not a line. You can't cut a line in half, right? Because the line goes on forever in every direction. So it has to have a finite length. Got it? Then you'll put your compass on one endpoint, and you have to make your compass over halfway. Okay? So maybe about 3/4 of the way across the segment. So you set your compass so that it's about 3/4 of the way across the line segment. Got it? Yes? No?
Yes.
Okay. Everyone's with me? Then you go up here and you make a mark. Okay, so you go up above, somewhere where you think, about where you think the middle would be. Okay, so up above, and you do the same thing down below, and you make a mark. And then all you do without changing the setting on your compass, you lift up your compass and you do the same thing and you make a cross there and there. Want to see that again? Here it goes. Ooh, move the compass over there. Make a mark there and make a mark there. Okay. Let's unpause this. So then you take your straight edge. Notice it's called a straight edge and not a ruler, even though it is a ruler. But we call it a straight edge because you're not using it to measure things. You're just using the edge of it. That's why they call it a straight edge rather than a ruler. What happens? What? No. Okay. I guess can't get away from these advertisements. Go away, you think. All right. So that's how you do it. Any questions on that? Pretty straightforward. Okay. That's not exactly everything we're doing, but we're going to move on. Now, if anyone have questions about how to make a perpendicular bisector, I want to show you one more thing that's kind of cool. Can I do it on here? I don't think they have, so I'm going to pause for a minute. So there's one on your homework where it says, draw a here to the bottom of this page. It tells you why this works, okay? If you were to prove why this is true, this would be a proof of why that works. And basically what you're doing, this piece is congruent to this piece is congruent to this piece, and basically you have 4 congruent triangles, and if those triangles are all congruent, this is using deductive reasoning, then these four angles would all have to be congruent, right? And if they're all congruent, what's got to be true about each one of those angles? They're all 90 degrees, right? So that's why it's perpendicular. And also, these segments have to be congruent. That's why it's a bisector, okay? So that's why it works. We'll tell you about that, okay? And then I'm going to click on this little triangle right here to get my GeoGebra. It gives me a geometry screen. And then I am just going to make a segment, okay? And so to make a segment, you take this tool up here, and you go segment, and you go boom, boom, and I want to tools, window, options, labeling, automatic, all new objects, all new objects, all new objects, automatic, new points only. How can I do this? Can I go label? Show label. There we go. There's point A. Show label. Show label. There's point B. To make a perpendicular bisector, it can't just make a perpendicular bisector. You have to find the midpoint. Okay? So what you do is you get this point tool right here, and you go, see this down here? Point on center. So you take this thing, midpoint on center. It's really cool. And you just click anywhere on this line. Anywhere. Boom. And it puts a point at the midpoint. And then if I go to this perpendicular line, there it is, perpendicular line. You click on this. Boom. And you click on the line 2. Boom. There's your perpendicular line. Isn't that amazing? It's cool, right? So now, if I drag this around, those two things will always stay perpendicular, and this is the perpendicular bisector of that, okay? Now, what I want to show you is a conjecture, okay? I'm going to put a point on this, just a plain old point on this perpendicular bisector. Okay, there's a point. And then I'm going to make a segment from this point to that point, okay? So I'm going to do segment, 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 from here to here, and then from here to here. Boom. Okay? And then I am going to take this tool right here. I was playing with this last night. Okay, if you click on this thing, this is kind of where you measure stuff. Distance or length. Okay? So I'm going to click on this. I'm going to measure this distance. And then I'm going to measure this distance. Okay? And then I'm going to grab my arrow. I'm going to drag this so you can see it better. Drag this. No. Grab my arrow. Drag this measurement. Measurement. I want the measurement. Where's the measurement? Move. I want to move this over here. Okay? What do you notice about those two lengths from here to here and there to there? They are the same. Now watch this. If I drag this point, are they always the same? Yes, okay? So what we have now is a conjecture which says, I'm giving you your conjecture sheet right here, okay? Which says that if a point is on the perpendicular bisector of a segment, then it is equidistant from the point. Okay? 1, 2, 3, 4, 2. 1, 2, 3. So this is a conjecture for the whole chapter. Keep this in your notebook. We'll fill these in as we're going along. Okay? It's also posted with a link on my Schoology. Okay? Well, you can't see that. You can't see those, but those are the same. So conjecture C5 says, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segments. You know how to spell equidistant? Just like it sounds. No, you wouldn't spell it just like it sounds. Let me see how you spell it. Equidistant. Distant. And The converse of that, C6, if a point, C6 says, if a point is equidistant from the endpoints of a segment, okay, where does it lie? It's on the what? What is this thing called?
Bisector.
It's on the perpendicular bisector of the segment. So it works forwards and backwards, okay? So in that case, the C5, the statement, it says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints. And the converse says if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. Perpendicular bisector. Okay? Got it? I'm going to show you two more things, and then we're going to be done. I think I'm going to show you two more things. Okay? I think I'm going to show you on GeoGebra, although you guys have to do it using your compass. Okay? But it's kind of quicker for me to show on GeoGebra. So I'm going to open a new sketch. I'm going to make a triangle. Okay? So this GeoGebra, I love it. Okay? Close this, get this, GeoGebra. I'm going to go File, New. No, I don't want to say it. Don't say it. Don't say it. I'm going to go again to get my geometry window. I'm going to draw a triangle. So to draw a triangle, you go this, any triangle. You just, no, that's not what I want. Polygon. Select the vertices. Polygon. That's what I want. So I'm going to go click, 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 any old triangle I'm going to make. Okay? And then I'm going to make a midpoint of one of the sides. Okay? Any side doesn't matter. So I'm going to take a point, and I'm going to go to point at midpoint. How would I construct a midpoint? Who can tell me how I construct a midpoint? There, now I'm recording. To make a mid-segment, let's do a new sketch. File. I gotta get out of here. Okay. File, new. Don't save changes. Okay, I'm gonna get my geometry board over here again. Okay. I'm gonna make a triangle. Let's see if I can do it right this time. There we go. Triangle. Okay. And I'm going to construct a midpoint on two of the sides. Okay? So I'm going to take this midpoint tool. You would have to do it with your compass. Midpoint there. And I'm going to make a midpoint, let's say here. Okay? And then I'm going to connect those two. Okay? So I'm going to get my segment tool, and I'm going to connect this point to this point. Okay? This thing is called a mid-segment. Okay? Segment. Okay? It's hard to write neatly. Okay, that's a segment connecting two midpoints on the sides of a triangle. Okay. So a triangle would actually have three mid-segments, like I could do one from here to here, and one from here to here. Okay? I just want to show you something real quick. If I were to drag this triangle around, notice that that mid-segment stays the mid-segment, right? It doesn't move. Anyone want to make a conjecture? There's something that's true about that mid-segment. What do you think the relationship is between this and this? They're parallel. There's something else that's special about it. What? It is, actually. Look, I'm going to show you that it's true. I'm going to go measure. Watch. distance and length, watch, boom, 3.48. So if what Jackson said was true, 6.96. Notice, I guess I can make the font bigger so you can all see that. But if I drag this point around, watch, 5.3, 10.6, okay? So that mid-segment, we will learn that, it comes later on in the chapter, but as long as I have here, that mid-segment is always half the length of that other side. And it is parallel to, like Drake said, okay? So, I think I'm done here.